How to calculate moment of inertia for this? We want to learn. For that, I imagine a small portion of the ring whose mass is dm. We take small dm. Total mass of the ring is m. And its radius, we take only for the inner radius, but usually it's compared to this thickness, this thickness negligible, and we can take inner and outer radii only same. Therefore, now moment of inertia for this, say, for this dm, I write dm r square. Is that right? Mass into radius square, distance square, plus dm r square, like this. I can write for all the dm's what we have there. That means you are supposed to integrate this. I is dm r square dm we write. With respect to mass only, because r is constant. Therefore, what we get, I is r square into m. R simply m r square, usual way I have to write. Because as, say this can be written as r square taken out dm. As you know, integral of dm is m, total mass of the ring. So m r square is the moment of inertia of the ring. Very simple proof. I hope all of you can understand this. I just go through it once again. Just think over it like this. Say we have a ring. We want to calculate the moment of inertia passing through its center and perpendicular to this. Say ring means over the axis always. Axis of the ring means always a perpendicular line passing through the center. That line perpendicular to the plane of the ring. Say we are imagining now ring is on the board. So an axis is this one, what is coming out or going on to the other side. For that, we consider a small portion of the ring of mass dm. I have written moment of inertia of this dm into r square. Then such, we can imagine many such dm's are there in the ring. So we have to add them. Instead of, as it is a continuous distribution of mass, instead of adding, we do integration. And r square is constant, you take it out, you will get integral of dm. But you know, integral of dm is m, so mr square r is the formula for moment of inertia. ಇನ್ನೊಂದು ಸಿಚುಯೇಷನ್ 2 ನಿಮಿಷ ಟೈಮ್ ಕೊಡ್ತೀನಿ. ಕ್ಯಾನ್ ಸಂಬಡಿ ಟೆಲ್ ಮೀ ಫಾರ್ ದಿಸ್? ಡಿರೈವ್ ಮಾಡಿ ಹೇಳ್ಬೇಕು, ಮನಸ್ಸಲ್ಲೇ ಡಿರೈವ್ ಮಾಡಬಹುದು. ಏನದು? ಐ ವಿಲ್ ಗಿವ್ ಯು ಜಸ್ಟ್ ಎ ಸಿಸ್ಟಮ್ ನೌ. ನೋಡ್ಕೊಳ್ಳಿ, just observe the things carefully. We have two particles of mass m by 2. Mass m by 2 with separation L. With separation L. You are supposed to calculate its moment of inertia, and we imagine these two masses are connected by a light massless rod. That means you need not bother about moment of inertia of this rod, which is connecting them. Say, I want you to get me the moment of inertia of this system over this axis, which is passing through the midpoint of the rod, which is connecting m by 2 and m by 2. Axis O. So this distance is L by 2. This is L by 2. I said it is midpoint. So m by 2, L by 2 whole square. Plus, for this now, m by 2, L by 2 the whole square. Do this calculation. How much you get? You just check. M by 2, L square by 4 into 2, because double is there. So 2 cancels. M, L square by 4. That's it. Very simple proof. You are supposed to think of this, my dear friend. Next challenge is up to you only to take up. Now we start deriving. There's a challenge for you people. So what is the challenge? Observe carefully. You are supposed to derive equations of motion for rotational motion, what we have written yesterday. omega equals omega naught plus alpha t. Theta equals omega naught t plus half alpha t square. Using calculus, alpha formula ಏನಪ್ಪ? d omega by dt. Rate of change of angular velocity. Now you integrate this. Almadic technique ಏನು change ಮಾಡ್ತಾ ಇಲ್ಲ ನಾವು. Writing this and then integrate. ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ? ಒಮೆಗಾ ನಾಟ್ ಇಂದ ಒಮೆಗಾಗೆ. ಈ ಕಡೆ ಇಂಟೆಗ್ರಲ್ 0 to t ಆಲ್ಫಾ ಡಿ ಟಿ. ನೋಡಿ ಎಲ್ಲ ಅದೇ ಪ್ರೊಸೀಜರ್, ಸಿಂಬಲ್ ಮಾತ್ರ ಚೇಂಜ್. ಇಲ್ಲಿಗೆ ಒಮೆಗಾ, ಅಲ್ಲಿಗೆ ಏನಾಗಬೇಕು? ಇಂಟೆಗ್ರಲ್ ಆಫ್ ಒಮೆಗಾ ಇಸ್ ಒಮೆಗಾ, ಒಮೆಗಾ ನಾಟ್ ಟು ಒಮೆಗಾ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು alpha constant, take it out, integral dt 0 to t. ಇಲ್ಲಿ ಲಿಮಿಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಒಮೆಗಾ ಮೈನಸ್ ಒಮೆಗಾ ನಾಟ್ ಆಲ್ಫಾ. ಇಂಟೆಗ್ರಲ್ ಆಫ್ dt is t 0 to t. ಒಮೆಗಾ ಮೈನಸ್ ಒಮೆಗಾ ನಾಟ್ ಈಕ್ವಲ್ಸ್ ಆಲ್ಫಾ ಟಿ. ಇನ್ನೊಂದು ಆಲ್ಫಾ 0 ಆಗುತ್ತೆ, ಬಿಡೋಣ. ಅಲ್ಲಿಗೆ ಒಮೆಗಾ ಈಕ್ವಲ್ಸ್ ಒಮೆಗಾ ನಾಟ್ ಪ್ಲಸ್ ಆಲ್ಫಾ ಟಿ. ವೆರಿ ಬ್ಯೂಟಿಫುಲಿ ಗಾಟ್. ಬರ್ಕೊಳ್ಳಿ ಎರಡು ಕ್ವಶನ್. ಡಿರೈವ್ ದಿ ಫಾಲೋಯಿಂಗ್. ಒಂದೇ ಕ್ವಶನ್ ತರ ಬರ್ಸ್ತೀನಿ. ಡಿರೈವ್ ದಿ ಫಾಲೋಯಿಂಗ್. ಫಸ್ಟ್ derive the following using calculus method. Write down. Using calculus method. First one, theta equals omega naught t plus half alpha t square. B, omega square equals omega naught square plus 2 alpha theta. Prove this by calculus method. Derive the following by using calculus method. ಅಂತ ಕೊಟ್ಟಿದ್ದೀನಿ ಕ್ವಶನ್ ಇವೆರಡು. ಟೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಇದು ಅಸೈನ್ಮೆಂಟ್. ಕಲ್ತಿದೀವಿ ಇದೇನೆ, ಬಟ್ ಸಿಂಬಲ್ಸ್ ಮಾತ್ರ ಚೇಂಜ್. ಅದೇ ಮೆಥಡ್ ನ ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡೋದು ಬರುತ್ತೆ. ಆಯ್ತಾ ಮಕ್ಕಳ? ಇದಾದ್ಮೇಲೆ ಒಂದು ನ್ಯೂಮರಿಕಲ್ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಬರ್ಕೊಂಡ್ರೆ ಎಲ್ಲರೂ ಈ ಕ್ವಶನ್ಗಳನ್ನ ಟ್ರೈ ದಿಸ್ ಲೇಟರ್. ಬೈ ದಿ ಎಂಡ್ ಆಫ್ ದಿ ಡೇ ಯು ಆರ್ ಸಪೋಸ್ ಟು ಗೆಟ್ ಮಿ ದಿ ಪ್ರೂಫ್ ಫಾರ್ ದಿಸ್. ಓಕೆ, ವಿತ್ ದೀಸ್ ಥಿಂಗ್ಸ್ ನೌ write down one more numerical. Write down the numerical there. The angular speed of a motor wheel. The angular speed of a motor wheel is increased from 1200 RPM. What does it mean? RPM, rotations per minute. 1200 rotations per minute, RPM, to 3120 RPM. 3120 RPM in 16 seconds. In 16 seconds. Full stop. Part 1. There are two parts to go. Part 1. What is the angular acceleration? What is the angular acceleration? What is the angular acceleration? Come on. Assuming acceleration to be uniform. Assuming acceleration to be uniform. Assuming acceleration to be uniform. Question mark. Part 2. Part 2. How many revolutions? How many revolutions? How many revolutions does the engine make during this time? During this time? Question mark. So look here. We are given with these things. 1200 RPM is omega naught. initial angular velocity, so many rotations per minute. And omega is final angular velocity, or you can write omega I and omega f, nothing. And then time is given t, 16 seconds. Alpha to be calculated, angular acceleration, and assume that it to be uniform. Then theta to be calculated, how many revolutions it completes. First we calculate it in angle, later on go for revolutions. So how to solve this problem? We are given straightforward everything, omega naught, omega t, alpha to be calculated. But observe, before calculating alpha, we have to convert rotations per minute into radian per second. Angular speed. For that, what we do, observe, 1200. This is how the conversion. Rotations per minute. One rotation corresponds to how many radians? 2 pi. One circle, 2 pi radians. Per minute is there. 1 minute equals 60 seconds. So divided by 60. Why I am writing 60? This means to say R rotations per minute. Rotations or revolutions per minute. RPM stands for the slash. P stands for slash. That means minute is in the denominator. 1 minute corresponds to 60 seconds. So this is. No. 0 goes 20. So 40 pi radian per second. Is that right? In the same manner, 3120 into 2 pi by 60. So this goes there, and 6 5s are 6 2s are. So 104 pi. 104 pi. This is also in radian per second. This is also in radian per second. We got both the omegas there. Both the omegas. Now, once you know omega value in radian per second, what is the formula for alpha? Just now you have proved now that itself omega equals omega naught plus alpha t. Substitute everything. 104 pi omega naught 40 pi plus alpha to be calculated into 16 time. So 104 minus, we write, alpha 16 equals 104 pi minus 40 pi. So how much it is? 104 pi and minus 40 pi? 64. So alpha 16 equals 64 pi. 16 fours are 64. So alpha is 4 pi unit. Radian per second to the power of minus 2. Radian second to the power of minus 2 or radian per second square. Alpha you got now. Once you know alpha, how to calculate theta? Second formula, theta equals omega naught t plus half alpha t square. Adaru ಬಳಸಬಹುದು ಇಲ್ಲ ಮೂರನೇದಾರು ಬಳಸಬಹುದು ಯಾವುದು ಬಳಸಿದ್ರು ಬರುತ್ತೆ ಮೂರನೇದು ಯಾವುದು omega square equals omega naught square plus 2 alpha theta. I want you to do second one. That's easier. So we write to calculate theta, to find theta revolutions. So how to do that? We use formula theta equals omega naught t plus half alpha t square. Substitute everything. Omega naught is 40 pi into 16 plus half into 4 pi into t square, 16 square. Do the calculations you will get. Keep the pi as it is. Don't substitute for pi. Pi to be substituted as 3.414 that we think of later on. So this is 240 pi. This amounts to be 2 pi plus 2 pi into 256. How much you get? 60 square is 256. Get me the final answer for this. Keeping pi as it is. 512, observe, 240 pi plus 1152 ಅಂತೆ ಇಲ್ಲಿ ಬರಿತೀನಿ ಮಕ್ಕಳ 240 pi ಇದು 512 ಆಗತ್ತೆ 512 240 ಅಂದ್ರೆ 712 762 ಬರುತ್ತೆ ಇಲ್ಲಿ ಬರಿತೀನಿ ಅಲ್ಲಿ ಕಾಣಿಸ್ದೆ ಹೋದ್ರೆ ಥೀಟಾ ಎಷ್ಟು ಬಂತು 1152 pi ಬರುತ್ತೆ ಈಗ we want to go for revolutions. ಇದು ರೇಡಿಯನ್ಸ್ ಅಲ್ಲಿ ಬಂತು ನಮಗೆ ಎಷ್ಟು ರೊಟೇಷನ್ ಅಂತ ಕೇಳ್ತಾ ಇರೋದು ಅವರು ರೊಟೇಷನ್ಗೆ ಏನ್ ಮಾಡೋದು ಟು ಫೈಂಡ್ ಇದು ರೇಡಿಯನ್ಸ್ ಆಯ್ತು ಇಷ್ಟು ರೇಡಿಯನ್ಸ್ ರೊಟೇಟ್ ಆಗುತ್ತೆ ಟು ಫೈಂಡ್ ಇನ್ ಅದು ನಂಬರ್ ಆಫ್ ರೊಟೇಷನ್ಸ್ ಟು ಫೈಂಡ್ ನಂಬರ್ ಆಫ್ ರೊಟೇಷನ್ಸ್ ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ಬೇಕು ಒಂದು ರೊಟೇಷನ್ 2 ಪೈ ತಾನೆ ಡಿವೈಡ್ ಮಾಡಿ ಥೀಟಾ ಅಂತಲೇ ಬರಿತೀನಿ ಸಿಂಬಲ್ ನ 1152 pi by 2 pi ಡಿವೈಡ್ ಮಾಡಿ ನೋಡಿ ಅದಕ್ಕೆ ಪೈ ನಂಗೆ ಇಟ್ಕೊಳ್ಳಿ ಅಂತ ಹೇಳಿದ್ರು ಮಕ್ಕಳು ಅಷ್ಟೇ ಅಲ್ಲಿಗೆ ಎಷ್ಟು ಬರುತ್ತೆ 2 5s 2 7s 2 6s so 576 rotations that is the answer 576 rotations if you cannot see that I write 576 rotations. So that is the answer for this question. Think of it. Next, we need to learn new concept after this numerical. Now we want to do that. How to write equations for work, power, and all those things. So we start with those things. Say in linear motion, work means force into displacement, force dot displacement. Here also same thing, force dot displacement. We try to do that. We'll see what we get. Or can you guess what is the work done in case of this rotational motion with before going for derivation? Tau dot d theta or theta can be or simply tau theta. Why? No question of dot that we think of. Observe carefully. I write down the expression for work done in case of rotation motion for a particle. One particle we think. Say this is the radius vector. Now we have a force acting on it like this. Observe carefully. Just observe the things carefully. It is rotating like this. We think of this particle is rotating like this. How to calculate the torque? For that, to make our life easier, calculations easier, I resolve this force into two components. One tangential to the path, one perpendicular to the path. This perpendicular to the path lies along the line of radius because radius is perpendicular to the circular path. Now, if we resolve this into two components, if I take this as theta, then what is this tangential component? For theta, it is adjacent side, therefore, f cos theta. This is f sin theta. Observe, torque due to f sin theta component is 0. R cross f, R and f are in same line. So R cross f means what? RF sin, ಇಲ್ಲಿ theta ಅಂತ ಹೇಳೋದು ಬೇಡ sin alpha ಅಂತ ಹೇಳೋದು ಹೇಳ್ಕೊಳ್ಳಿ ಅಲ್ಲಿಗೆ sin 180 ಅಥವಾ sin straight line 0 alwa sin of 180 or sin 0 is 0. Therefore, torque due to this component lying along the R is 0. What else there? Only this component. What is that? Say I write torque F cos theta F cos theta R. I write RF cos theta. RF cos theta. Got the point? RF cos theta. Let it be there. We'll keep it aside. Now we start with work done formula. W for this. This will not do any work because displacement is this way. So what I have to do? F cos theta into say ds or something, displacement in this direction. Here, the displacement. F cos theta is tangential, F cos theta into ds. Got the point? So by using this idea, I can simply write in the same manner where we can write it as again tau d theta I can write. But that's not required. We can straight away write down work done as tau theta. Tau is RF cos theta d theta. RF cos theta d theta. Like this. So this is what we do for work done during rotational motion, or simply we always use this. For small angular rotation, tau theta, keeping tau as constant. When force is said, when torque is constant, we can write